In the previous slide, we learned about how to interpret the pH, the CO2, and the bicarbonate. This time we're going to learn more about the concept of compensation. Now that you know that this is the scenario, how do you know if compensation is going on? In order to know if compensation is going on, you have to look at the bicarbonate and the carbon dioxide. You will know that compensation goes on if the direction of the bicarbonate is the same with the direction of carbon dioxide, or the direction of carbon dioxide is the same with the direction of bicarbonate. Hence, if bicarbonate goes up and carbon dioxide goes up, you are going to have compensation. If bicarbonate goes down and it's the same thing with carbon dioxide goes down, it means that there is compensation going on. So let's have this drill. In this drill, we're seeing that the pH goes down, acidosis. The carbon dioxide goes up, so what is your interpretation? Based on the first video clip, we have respiratory acidosis. Here, the pH goes up and the carbon dioxide goes towards the opposite. Based on video clip number 1, we already can interpret respiratory alkalosis. In the third scenario, the pH goes up, the carbon dioxide goes up, and the bicarbonate goes up. We know that this is metabolic alkalosis. And if the pH goes down, the carbon dioxide goes down, the bicarbonate goes down, this is metabolic acidosis. So the question is, how do you know if compensation is going on? Well, here we see that there is compensation because carbon dioxide and bicarbonate goes towards the same direction. The same applies here. Both carbon dioxide and bicarbonate goes towards the same direction, so there is compensation. What about here in number 1? How will bicarbonate compensate? By going towards the opposite or the same? It has to go towards the same direction. And now that carbon dioxide and bicarbonate goes towards the same direction, there is compensation. The same with carbon dioxide here. What should be done by bicarbonate in order to compensate? Bicarbonate should go towards the same direction as carbon dioxide, hence it has to go down. So looking at these, 1, 2, 3, and 4, we already know that compensation is going on among these 4 situations. So this is compensated, 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 compensated. Which brings us to the last question. How do you know if it's partially compensated or fully compensated? Now, this is easy. All you have to do is look at pH. If the final pH is normal, then that's fully compensated. If the final pH is not yet normal, then that's partially compensated. So let's apply. Here, we see that the pH is still not normal. So this may be partially compensated, respiratory acidosis. Here, the pH is not yet normal, so we can conclude that this is partially compensated. Here, the pH is still not normal, so we conclude that the interpretation should be partially compensated. Similarly, here we see that the pH is still abnormal, so this will be partially compensated. So all of these, since the pH is not yet normal, they're all partially compensated. Now, let's try to summarize. As we summarize, we go back to video clip number 1. In video clip number 1, we learned that if the pH goes down, that's acidosis. If it goes up, that's alkalosis. If the CO2 will go towards the opposite direction of the pH, then we are going to make the final decision. That's respiratory. Otherwise, we look at bicarbonate. And if we see that bicarbonate goes towards the same direction with the pH, we decide that is metabolic. And in order to detect compensation, we have to look at carbon dioxide and bicarbonate and see if both are going towards the same direction. If both will go towards the same direction, then there is compensation. But then the last question, is it partial or full? If the pH is already normal, then that's fully compensated. But if the pH is not yet normal, then this is partially compensated, acidosis or alkalosis. So in order to do the entire process of interpretation, again, you may watch video clip number 1 and continue with this video clip number 2 and apply it in different kinds of exercises.